Thank you very much. It's a real privilege to be here and to be with you. Unfortunately, I must tell you, I must leave after lunch for the following reason. We have neighbors. The gentleman is an emeritus professor of neurochemistry, a Chinese family. Tonight is their 50th wedding anniversary. That could not be changed, and I feel I must be with them. I started my graduate study in genetics 50 years ago this fall, at a time when there was no department of genetics at my university. 7 years later, in 1953, my wife finished typing my PhD thesis through 5 layers of onion skin with 40 tables. On that day, our son was born. But do you know what else happened in 1953? The Watson and Crick paper, which is one of the reasons we're here. When I got into genetics, there was a sense of fatalism. People said, if it's genetic, what can you do about it? And the tide has turned. Over the years, it's been my privilege to continue to work in this field. I have tended to work in studies that were not always at the front of things. Often if there was a question and people said thus and so, I said, is it really true? My professor, for example, was interested in the idea that people with larger families in schools tend to have lower grades. Now, if you're from a large family, don't take that personally. It's a statistical statement. He said, that's a mistake here. When you look at schools, you are looking at those who have had children. And so we had a rather massive study. And when you take a full group of adults and score them on some measure of ability, there is absolutely no difference across, if you will, IQ levels and reproductive levels. So a question, go and look and see. At the moment, I'm working on the field of epilepsy, and my PhD thesis on breast cancer has been renewed after Watson and Crick, when we can do something more about it. What I will do is 3 things. I will look at somewhat of a critique, and I appreciated Dr. Fahey's point about discriminating judgment. We will need to look at things where there are criticisms and say, does it have to be that way? Is it that way? Can we change it? A little bit about the history of genetics, and then briefly from the scripture. Now, the fine print I will only summarize. One of the best books in this area is entitled Are Genes Us? That sounds like a reduction, does it not? Charles Weiner is a professor of the history of science at MIT. I have met him. One of the things he has done is to take taped interviews with all of the people, or almost all of the people, who have been involved in the DNA story. So taking taped records and then filing these will be very, very important for generating a history. On this, he has taken the 4 letters of the genetics alphabet and done something else with them. As you know, there are 4 nucleotides, and the whole mystery of everything else is based on a pairing. A is always opposite T, and G is opposite C. And so what has he done here? G means geneticize. Make it genetic. This removes it from other categories. A is for advertise, and the power of the dollar is extremely important. You need to realize that the genetic associations have been telling groups, It's too early to use this test. Don't let this kind of test be used yet. We do not know, we don't have full enough information. We can't do the appropriate counseling. So there is something that's negative there. T for trivialize, say, oh well, we've got this problem, they've always been around, forget, don't worry about it. And then compartmentalize, notice that. Create a committee to study the situation and be sure that science doesn't get slowed up in the process. Well, these are ideas that have to be considered here. In that same book, there is a discussion about the metaphors that are used in science, that are used in genetics. How many metaphors? The genetic language, the genetic code, the book of life, translate, and so on. Those are very interesting and valuable metaphors. But are there times when a metaphor begins to take on meaning in itself? Here are two statements. Notice in the upper one the terms law code, executive power, or to use another simile, they are architect's plan and builder's craft all in one. Now that's an overkill, I would say. It's very interesting, but we often use metaphors of this type. Schrödinger wrote a book on what is life. At the bottom it says, a tool for deciphering the mysteries of its own existence, the mystery of life. There is a sense in which DNA is the mystery of life. There is another sense in which you cannot code and decipher the meaning of life in its fullness. I will summarize by saying that genetics is necessary but not sufficient for understanding human nature. Another feature of interest is the way in which we name a gene. You've heard these, and if I had time here, I would ask you to add to this list. A criminal gene, alcoholic gene, obese gene, a novelty-seeking gene, a cancer gene. This gives the impression that you can characterize a condition in a gene, and sometimes characterize a person. My intuition is to say, if you ask me about those, I'll have to go back and see what was meant by the study. How did they carry this out? How many people? What is the evidence? But furthermore, to realize that genes interact with so many other things. To really understand the biology, there is much more that we need to know. So this is part of our issue here. To what extent do we reduce people to a gene? Let me next comment on something about a concept of levels. I realize that there are other ways of dealing with fields of knowledge, more complex than this. How do you put theology in it? It's not a simple line, but somewhere up to the top in terms of the scope that it carries. But now let me point out two things about the DNA story at the very beginning. The relationship between physics and chemistry and biology. Reducing is sometimes used in the sense, can we deal with all of chemistry if we understand the physics? Can we reduce chemistry to physics? If so, can we reduce biology to physics? Is this reduction possible? Before Watson and Crick, the physicists had a good idea as to the size and nature of the DNA helix. They knew it was helical, they knew it was double-stranded, they had the idea of the the number of coils, and the dimensions. But it still did not work. Schrödinger had earlier said the issue is genetic information. But there was a sense in which thinking physics put you in terms of structure that was not interpretable in terms of biology. What does a gene needed for in the biological sense? The gene's characteristics need to be such that the gene can be copied faithfully and that it can carry information. Watson and Crick said, aha, in their one-page paper, essentially, this will work if these nucleotides are put in the center of the helix. That is, going from the bottom up did not resolve the question. You had to use ideas or questions from the top down. This helped then. This changed the concept, the model of the DNA, not made out of balsa wood, you understand. This is a conceptual framework. But lo and behold, after you've gone from the top down, the bottom up then also works. The frustration philosophically of top-down thinking and bottom-up thinking finds itself sort of illuminated in this history of the DNA. Now, there is another way of dealing with the relationships. Note that genetics operates at all of the levels of biology. The molecule, the cell, the individual, the family, and the population. It is almost unique in that way. This is why genetics infects all areas of medical training. It has an effect upon all of them. What can we learn from this kind of relationship? There is an interesting paper from Hungary in which a physician there says he is troubled because the emphasis on the DNA at this level appears to be diminishing the concern for the patient and for the broader community. Specifically, in Hungary, over a 5-year period, the recognized frequency of trisomy 18 was cut in half. So it hasn't changed, but the physicians were no longer interested in or capable of making that diagnosis in the patient. Here is a part of the problem. And in a sense, from my point of view, this diagram may serve as a model for a way of thinking about avoiding the reduction of the individual. Have you read Jurassic Park recently? What is the theme in mind? Those individuals, those scientists understood the DNA, but they did not understand how genes affect behavior of individuals in populations. Do you get the point? They completely missed that. Furthermore, there are some interesting little episodes, little conversations in this. At one point, and I've forgotten who it was, says, you know, a young scientist is like someone who has received a big inheritance that he had no part in making and doesn't know how it should be used. And so there is a tendency, a possibility, that in training molecular biologists, they have no interest in or concern for or awareness of the implications of their work for the higher levels, if you will. We cannot sacrifice all of biology at the molecular level, disregarding the patient and the population. I have somewhere a punchline that I was supposed to read at this point, but I don't find it. Ah, no. We'll disregard that. I want to do two other things with this. Here is a very long quotation. It's a complicated way of saying something, which I will tell you in simpler terms. This is a paper talking about the relationship between genotype and phenotype. What is the direct connection? What I've written here perhaps says better. The genotype to phenotype relationship is neither unidimensional, programmatical, nor hierarchical in a strict sense. What happens in the nervous system? Early in that development, genes set out the segments of the nervous system from the head end on down. Then there are other genes that begin to form cells, lead to the formation of cells, which then begin to migrate. As time goes on, the migration of those cells is less under the direct control of genes, but much more under the control of the environment in which the extending neurons find themselves. That is, the control is fairly close at the beginning, but it becomes more and more diffuse. As these neurons get out there, those that form synapses are saved. Those that don't are programmed to die. But that is a chance kind of thing. It's much more indirect in that sense. So you cannot believe the story that you may once have thought, that genes specify development like an architectural plan. It's much more like an architectural plan, and the architect says, this didn't work out, okay, we better change that, etc. It is a shifting kind of story. So genetic determinism is, in its strictest sense, ruled out by our current understanding of the relationship between these various levels. Let me go back to this and point out the role of Jesus as healer. And the healing work of Jesus was not only at the individual level, it was also at the community level. When he healed some, he sent them back into the community. So my admonition is to urge that we think of this in its composite, in its fullest sense. We use the molecular information as much as we can, but we try to see it applied also carefully to the individual, to the family, and to the much broader community. How does this relate, for example, to the work of gene mapping? I'm working on several epilepsy genes currently. My job is to help to find families. I do not do the molecular work. It is not as simple as you might think. One of my concerns is to work with clinicians and say, don't fool yourself. Molecular biology is not going to remove your position. You still will have a place. We still need to have the clinician shrewd enough to make a diagnosis, a very good diagnosis, and then to understand whether in some families there is a similarity between this in one child and the other child, occasionally in the parent, in other relationships. We can't do any mapping of genes unless we have that. Eventually this gets turned over then to the statisticians, to the molecular biologists. And one of these traits, very early, a seizure, which is strictly genetic. We have one family with 70 affected. Seizures occur in 80% in the first week of life. We know that now. We still don't know what the gene does. But I now have to find as many families as I can, because if we find a particular change in one family, does it the same thing in another family? What about various populations? We're looking for a family in the Navajo area. We have an Inuit family. Are those the same mutations? we have to go back and forth. When it is understood, we go back again to the clinician. How will this help you in your diagnosis? If there is a treatment, how will it help at that point? Okay. Nigel referred to the book that we had written, and it is a book about stewardship, applying stewardship to biology, even the doing of biology. And we identify 3 terms: the emphasis to fill, to master, and to tend. Any one by itself would be totally misleading. We look upon filling as being not merely quantitative, but also in making complete, filling out in the more qualitative kind of sense. What happens if we use this model and try to think about the way in which we can serve our Lord? My final point is simply to say, I will not give you my answer to this, the temptation of Christ. To what extent are his temptations paralleled in the temptations that we face in genetics? I think there are some very strong parallels. Not that our temptations are like his, but we are tempted like he is in that way. I agree with the admonition that we thank God for the good gift in the DNA, that we seek to use it wisely. We seek to honor and worship him by our lives. Thank you.
You probably read it by now. And this quotation from an article in Time magazine eloquently expresses what has been called the geneticization of people. People being reduced to genetics, or rather to their genes. Even the seemingly innate religiosity of the human being is ascribed to the genes, and the genetic blueprint is presented as rather determinative. One author defines geneticization as follows: an ongoing process by which differences between individuals are reduced to their DNA code, with most disorders, behaviors, and physiological variations defined, at least in part, as genetic in origin. It refers as well to the process by which interventions employing genetic technologies are adopted to manage problems of health. People reduced to genes. Hubbard and Wall, in their book, Exploding the Gene Myth, have given many examples of this thinking. It is difficult to say how widespread this thinking is among the general public and scientists, but I think it is undeniably there, and it's likely to be furthered, willingly or unwillingly, by the Human Genome Project, unless we take care. And I'll try to trace the methodological background very briefly and generally, because of the time, of this thinking and present a criticism. Modern genetics, like medicine in general, is based primarily on principles and results of natural science. Modern science is characterized by a specific way of investigating reality in which we live. Scientific approach to reality implies a reduction of the real thing or the individual creature under study to an impersonal object, taken out of the context in which it naturally or normally is situated. As a consequence, only what can be perceived by the senses, directly or indirectly, is taken into consideration. The search for the origin of things is transformed into a question about material causes. Reflections on the essence and meaning of things are replaced by querying their function and usage. As long as the specific and limited nature of scientific knowledge is recognized, it can be used valuable and useful, as we all know. However, in the course of modern Western history, there has been a tendency to overestimate scientific and technological knowledge and to consider that which is presented in the scientific models as the real, or at least the really important world. What's one thing to use a certain methodology to study reality, to set up models of certain phenomena, and to have specific questions answered in a way that allows some intervention, but it's quite another thing to consider these abstract models as true representations of reality itself, thereby conveniently omitting the notion that the models are a reduction of reality. For dealing with reality on the basis of those reduced representations leads to a violation of reality. But unfortunately, this is what has happened to varying degrees in mainstream modern medicine. Mainstream modern medicine, the explanatory strategy, can be rendered with the words reductionism, dualism, and determinism. You find this here. This is a scheme taken from an article by Voss. Reductionism manifests itself in the fact that the machine has become the main metaphor for the human body, even though it may be seen as a genetic, neurological, hormonal, informational processing machine. So quite complicated, but yet a machine. And also in the understanding of disease as physiology gone astray. As a consequence, basic sciences like physics, biochemistry, and molecular biology are considered the basis for the applied sciences that make up medical science, as you find them here. Determinism shows up in the modern so-called medical gaze, in which the human being is, as it were, reduced to genetical, physiological, and mental processes that, in principle, could give a causal explanation of diseases and disorders at the material level. The mind-matter dualism of modern science manifests itself in medicine in three forms: the mind-body dualism, so-called Cartesian image of man, and the dualisms between the human being and its natural environment and its social environment. This approach leads to a deterministic view of mankind. I'm not saying that doctors are just looking at patients all the time in this way, but as much as medical practice is considered an application of science and natural science, human beings are reduced to these models. In medical genetics, the predominant medical model find a particular expression in the so-called central dogma of molecular biology. Central dogma. The name itself is very interesting. This states that a hereditary information is stored in DNA in the form of a code, and that this information is expressed by two sequential processes called transcription into RNA and then translation into proteins that are essential for the expression of individual traits. In other words, the genetic information encoded in DNA determines the phenotypic traits of an organism through the direction of the synthesis of proteins. The flow of information occurs in one direction, from DNA via RNA to proteins and traits. A gene is defined as a unit of heredity containing the information for one protein, although this is very much discussed now in molecular genetics, of course. This model clearly implies a rather deterministic view of mankind. The genes determine how the individual will be, or at least how that individual can be. The environment, both the natural and social, influences the extent to which certain traits will be expressed, but not the character of the genes or the traits themselves. They are considered fixed entities. This model clearly invites to study the genes in order to understand the human body and diseases and try to control it. Sidney Brenner in 1989 expressed his view on genetics as follows. He's one of the well-known geneticists involved in this Human Genome Project. Genetics investigates the plan of the organism. This plan is embodied in a collection of genes that is handed down in the germline to specify the construction of the organism. At the end of his lecture he said, the manifesto, if not the program, of molecular genetics must remain the computation of organisms from their DNA sequence. Understanding the language of genes remains the major scientific objective of all genetic research, unquote. It is clear that the prevailing approach in modern medicine has been very successful in elucidating the functioning of the human body and in discovering causes of many diseases at the material level. And this has resulted in many possibilities for therapeutic and palliative interventions that has been and continue to be of great benefit to many people. I'm not discussing that. At the same time, we are becoming increasingly aware of the limits and the insufficiencies of the just described predominant understanding of medicine in general and genetics in particular. I think its theoretical framework, though effective in certain respects, is inadequate in others. And furthermore, the very character of medical genetics, because of its inadequate theoretical framework, constitutes a danger to medical practice. And I'll develop both briefly. Theoretically inadequate. We saw that the so-called central dogma of molecular biology is still a leading model in molecular biological and anthropogenetical research. But this model oversimplifies and overstresses the role of the genes in organisms, especially in humans. Correctly understood, the model presents a simple model for the biophysical and biochemical relationship that exists between a particular nucleotide sequence in the DNA and the structure of a particular protein, at least the primary structure, the sequence of the amino acids. The structure of a protein determines its function given the right circumstances. However, the relationship between a specific protein and the expression of a trait of an organism under normal conditions is mostly unknown, even for microorganisms, let alone for the human being. The relation between the biochemical structure of proteins and the structure of organs or an entire organism are probably only indirectly related. François Jacob, a French molecular biologist, has formulated it as follows. During the development of the embryo, the world is no longer merely linear. The one-dimensional sequence of bases in the genes determines in some way the production of two-dimensional tissues and organs that give the organism its shape, its properties, and its four-dimensional behavior. How this occurs is a mystery. So to postulate a straightforward relation between DNA sequences and traits is unfounded. And I want to briefly mention epistemological objection also against this view. One not only speaks nowadays of genes for physical traits like color of eyes or hair or whatever, but also for behavior, like obesity, Alzheimer, manic depression, schizophrenia, alcoholism, homosexuality, and so on. In some cases, claims of having identified genes for one of these conditions withstood the tests of criticism only for a short time. Similar claims are being made time and again. Such claims do not sufficiently distinguish between two kinds of knowledge. Molecular biological knowledge of DNA sequences of a certain individual differs fundamentally from the knowledge comprised in a clinical diagnosis of an individual patient. The former, molecular biology knowledge of DNA, concerns scientific knowledge marked by the abstractions of the scientific method, whereas the clinical diagnosis relates to the health condition of a unique individual in particular circumstances. In the process of making a diagnosis, general scientific knowledge is not just applied. Clinical work is not just an application of scientific extract knowledge. This scientific knowledge is included in a cognitive process that is not so much marked by reduction and objectivization, but by recognition and judgment by which the scientific knowledge is integrated and interpreted in a wider framework of data, insights, and meanings. The two forms of knowledge, clinical and molecular biology, presuppose two different epistemic attitudes and cannot therefore be equated. That a few cases of specific gene defects lead to specific diseases do not disprove what I just said. It only proves that genetic information is essential, but it is not enough. It does not define the individual nor its characteristics as a whole. It also is a danger to practice. To a large extent, medical science is characterized by abstract scientific models about the functioning of the human body and about the deviations of normal functioning that constitute to or correspond to diseases. But when dealing with actual people in practice, the limitations of the models can easily be forgotten. Clinical work uses scientific data, as I just said, but not just applies them. It's much more complicated. So when it goes back to application of scientific knowledge and scientific models, the real people opposite to the physician that are consulting the physician are seen, as it were, through the spectacles of these models and being reduced to cases. We have heard examples already these days. The phenomenon that in modern society people have high expectations of science and technology, and that science and technology to a certain extent even have become the interpretative and meaning-giving framework for many people, makes the danger even bigger. In other words, the medical model has been internalized by many people, not just by medical scientists and physicians. This is shown a little bit in this sheet. Obviously a couple that lost their way, and the woman says to her husband, "Why don't you ask the way?" Upon which he answers, "Because my genetic..." Oh, sorry. Yeah. "Because my genetic programming prevents me from stopping to ask directions. That's why." Again, I don't know how far this has been internalized by people, but it is true that in the general public, people often refer to their genes as causes for the way they behave. There even has been a suit in court upon which a person who had committed murder referred to his genetic background, that he came from a family that had a gene that would predispose to criminality. He lost the case. But the fact that it was seriously used as an excuse, whereas the scientific evidence is very shallow indeed, at least as in a determinative way, shows that in this society people tend to find simple causes for things in order to keep life orderly and dominate and control our condition. In society, the genetic explanations could be used as a convenient way to address, or rather to elude, difficult social questions. The model of the gene as a blueprint, as determining factor and as a source of good and evil, nicely fits into our pursuit for control over life and health and security. However, the consequence could be that genetic manipulation becomes the manipulation of human beings. I like to show, just to show this as a visual expression of complexity. It's more kind of a joke than serious, but this shows the relationship between genic endowment and the growth of neurons, certain type of cells. You know, it's not a simple line, as you'll see. But others have said the same also. But it's very important to realize that. Another approach, I think, for understanding the gene, I'm going to close, is necessary, and I'll try to give some ideas about this tomorrow in the parallel session. I will stop with a few more remarks. Today in medicine, we often hear, either explicitly or implicitly, genes is the answer. But what exactly is the question? No doubt many researchers and doctors sincerely try to find therapies for people with congenital diseases. No doubt about that. And hopefully they will find them. But I cannot help having the impression that the whole genetic enterprise is permeated by another question, or should I say, by another quest, to which genes are or may seem to be the answer. This is the quest for paradise restored with human technology. In their interesting book, Bioethics in Europe, the authors write, once the basics of genetic engineering have been mastered, almost anything is possible in terms of manipulating the materials to achieve a desired effect. Fish can be altered to enable them to tolerate low temperatures. Plant breeders can produce crop resistance to drought or disease. Already fruit and vegetables that stay fresh longer or ripen more slowly are appearing on supermarket shelves. A famous French molecular biologist, Daniel Cohen, writes in his book Genes of Hope about the promises of the new technologies. I quote, and I have made an English translation of a German quotation of a French book. So I must say, I hope that this translation still correctly communicates what it said. But okay, there we are. First, in from now on to 10 to 100 years, it will make it possible, these technologies, to cure sick people, the physically and mentally sick people. End quote. Later on, this Daniel Cohen says, we will be able, I quote again, to produce a human being that is more complex and complicated, and more subtle, more distinguished from the animal than lives today, end quote. And he also writes, away with the dictatorship of natural selection. Long live the lordship of mankind over everything alive. This is a leading scientist. To me, these quotations sound like an echo of the words of the father of Solomon's house in Francis Bacon's Utopia, New Atlantis. And I deal the perspective of Alan Verheij on Francis Bacon's writings in this respect. Recognizing the Christian duty to provide help and healing for ill and invalidated people, Christian eschatology teaches us not to expect a utopia as a creation of human science and technology, but to expect God's recreation of heaven and earth. And those wild pretensions can easily turn the new genetic technologies that certainly can have very fruitful and helpful uses into a weapon against true humanity in our society. Thank you.
Well, we have some time now for some discussion. I think I'll begin by asking whether our two guests have any brief comments they want to make about each other's presentations.
If we had gotten together ahead of time, we would have lost some of the spirit of it, perhaps, and we would have had a very good time interacting. I think we're on the same wavelength, and our two backgrounds are sufficient that I really enjoyed it.
Well, who would like to engage in some discussion or raise a question? There are microphones in the aisles. Perhaps you could begin by saying who you are, so it'll help us to begin to get to know where we are coming from.
Frank Young. Elving, I want to first thank you for your many, many years of leadership in genetics and in this interface between society, theology, and science. I was struck by your analogy of the young person that received a large inheritance and did not know what to do with it, as you described and alluded to the current newly minted PhD. From your vantage point on the mountaintop, if you were to give advice to the young people in the audience that were looking to labor now in the post-Watson and Crickonian era that you received your degree before, because they're going to be outdated in about 10 years, what would you say would be the most significant things to venture into to bring forward the cause of the integration of science, faith, and public policy?
Wow. I would certainly encourage people to use reductionist methodologies efficiently and effectively, to try to use these in areas that have broad meaning, application, so they would impact on the kinds of concerns we have here, but perhaps in areas that others might not tackle. This idea of treating the poor. There are kinds of concerns that do not lead to big income from drug companies. And so maybe there are those, but use reductionist methods, but then always try in some of these to reconstruct or synthesize or show the relevance, the relationship of your particularly narrow research strategy to the broader world, so that you can't cover everything. God will guide you into an area of work, but try to understand the relationship between a reductionist and a synthesizing relationship, and put things back into wholeness, at least in the area of your particular research.
Thank you. So,
My name's Eric Windishman. I'm a student here at Trinity. Where does genetics end and humanity begin? Rather than reducing a human to genetics, what distinguishes humanity from genetics?
Genetics is a scientific branch. I think making the opposition, as it were, humanity and genetics, is a wrong kind of dichotomy or separation. Genetics is a specific approach to studying the living organisms and the human being, as there are many approaches and many angles from which you can look at a human being. So genetics is involved, in most general terms, maybe I could say, is involved in the interesting characteristics of organisms that the progeny has characteristics of the parents, so to say. Or you can also say that there is constancy in nature, and that as the Genesis says, God created the organisms according to their kind, or how does it say in English? That refers to a certain constancy. And genetics is dealing with that constancy and with characteristics. But the point, I think, is that genetics and genes have become too much of a fixation. How am I going to explain this? I think that the concept of genes today is still very much the same concept that Francis Galton had. What Dick was explaining this morning. And that makes it dangerous as units of information that are determinative and steering an individual. Whereas I think it somehow is a material basis for constancy in a very complicated way. And I think that genetics should be much more, as soon as it is applied to human beings or to clinical practice or anything, much more integrated in a much more holistic view of the human being, and far less as a kind of directive unit of information. But these are just a few remarks.
Francis Collins from the National Center for Human Genome Research. I'd like to challenge, Dr. Jacobson, your presentation of the typical medical geneticist as being as reductionist as you have portrayed him or her. The notion that medical genetics is theoretically inadequate, as you have stated, rests upon this naive idea that you are I believe, presenting medical geneticists as uniformly espousing, namely that this particular DNA sequence change is going to lead to this particular clinical manifestation. And while there are circumstances, say Huntington's disease, where an individual who has an expanded triplet repeat of that gene, if they live long enough, are going to come down with this neurologic disorder, most of the time that's not the case. And we have terms for that like penetrance and expressivity. And I think the more sophisticated medical geneticist lives every day with that kind of uncertainty, recognizing that most genetic alterations change risk but do not create absolute all or none probabilities. And in fact, all of medicine is going to have to learn to deal with this as genetics moves out of the specialist clinic and into the hands of every primary care physician, who will find themselves sitting across the desk from somebody trying to interpret a genetic test that says this person's risk of colon cancer is threefold elevated. Does that mean they're going to get it? Does that mean they probably aren't? This kind of statistical statement is going to be very difficult for us, I think, to integrate into sort of a human process which is not very good at understanding, either on the part of the physician or the patient, what that really means. So while I understand the point, and I'm often the one making the same point, that we can't afford to slip into this kind of reductionism in our interpretation of DNA sequence changes and their consequences, I think maybe you've overstated the nature of medical genetics as being a major source of that confusion. In my view, the confusion much more commonly comes from the public media, who are very fond of saying the gene for this, the gene for that, it's all in your genes, genes are us.
Could well be that I have singled out a certain line of thought, which I think has its roots in very methodology of modern science as it's predominantly being done, that the scientists themselves know it's far more complicated, I realize very well. But yet, it is also the scientists, and I have quoted a number of them, of leading scientists, who, when selling their work, as it were, to the public, are using these models. And so are fueling also this kind of thinking. And at the same time, we should realize that this fits in, as I just commented very briefly on that. It fits in with a whole concept of life and of the pursuit of our culture to control life, to control our conditions, and to reduce insecurity and uncertainties. And that makes this model so attractive to our culture and so dangerous. And that's why I think we should really be very much aware of it. But I agree, and I do think that as time passes on and more discoveries are being made of the complexity of the human being and the role genes play in a whole web of interactions and so on, that hopefully that understanding will also more go to the clinic and to the geneticists who counsel people, and then the genetic information will really be integrated in a more holistic approach to a human individual being.
I think that the concept, just reflecting on what you just said, relates to the premise stated earlier, to go one step beyond, to understand not only the person the scientist, who he is, not only what he says, but who he is as well. The homosexual gene was discovered and preached, which is actually just a polymorphism, as I understand it, by a practicing homosexual who really wanted to justify what he does and what he is. I would like to ask Dr. Anderson to comment on his extensive understanding of the human nervous system and how complex it is, and to talk about polygenetic disease and how many genes interact in order to make certain characteristics, to illustrate the complexity of what is going on when you try to talk about genes determining traits, or genes particularly determining behavior.
Let me give a try to that. Across all of the traits that we have, there are rare instances in which a specific gene is so dominant, is so devastating, that you can almost say it is the gene for that. There is one only in the world family in the Netherlands where there is a kind of violent aggression which is the result of an enzyme deficiency involving monoamine metabolism. It's so devastating and so direct that you have to say there's a direct connection. It's of interest that only one of these men was put into prison while the others were committing acts of attempted murder and self-display and rape of their sisters and all of this kind of thing that they could have been. But then we say, are there lesser degrees to which these enzymes are affected? Could these account for other things? And we don't know that yet. And so that's one approach. There is another way in which it isn't a matter of strictly polygenic, but where there are alternative genes. We know that now for Alzheimer's and for Parkinson's and for things like that, where it could be this or this or this. Presumably there is some common end pathway. I think that's the problem we always have, and we do not have for nervous system traits as good a clue as we do, for example, in cholesterol metabolism. In biochemical ways, we can have a much more precise way, partly because you can use experimental models to do this. But this is one of the goals, I think, and it is something where actually this group might think of a few selected behaviors or aspects of the nervous system that would be the most troubling, that would have the greatest impact upon persons. And maybe we're not searching in the right directions. It is frustrating that for schizophrenia and manic depression, we know that genes must be involved to some extent, and been extremely frustrating. It would be a great help if some breakthrough would happen. But there are going to be many individuals with less severe manifestations that still would need help. For many of these things, I think it is true that simply only biochemical intervention is not the only way to go. I'm switching from your question to say we need to have medication always with something else, with instruction about other elements of lifestyle, with instruction to family. These men in the Netherlands, this is a periodic kind of thing. Why? I'll bet even there some kind of counseling to family might reduce the triggering episodes that might help them.
Thank you. Well, we have time for one more question. If you have one more question for us. Sam.
Sam Casey from Christian Legal Society. Don't really know to whom I should direct this question, although both of your presentations were chilling to me in terms of what the legal profession will do. The central question that I have is this: if we should not reduce people to genetics, I agree. But right now, in the expertise, in the scientific expertise that you both represent in daily commerce in, is the normative rule that the gene, is it personality or is it property? In other words, at that molecular level, before we get to the higher community and the family, at the lowest level, what is your view of your communities, of your scientific communities? Is the gene personality or is it property? Because in the end, the scientific community doesn't get to make this decision alone. Some judges or legislature or other public process is going to be trying to put it into a current construct. And the big one is a gene personality or is it property?
Let me talk with you afterwards. I'm not really grasping your use of the word property. And I would need to go through that somewhat more. I have done some writing with regard to the possible impact on views of responsibility. And there is, I believe, legal opinions not responsible for reasons of. It's possible that the growth of genetics will give other means of diagnosis, perhaps some other rubrics or reasons that might fit under this. There will need to be continuing integration, collaboration, and I'd like to continue this with you. I think it really is, well, I can't resolve it here, but this is going to be happening, and we need to keep in touch.
Time is just almost finished, but a final comment from Dr. Jochum.
Yeah, the problem here is, I think, that in juridical terms, you have only two kinds of things, or either persons, personality, or things that are property, and can be property of somebody. And now, if genes are property, then you can ask, are body parts, organs, are they property? And this is an interesting matter that is discussed in medical ethics all over the world, I would say. And I would think that maybe in juridical terms we have to come up with a third category. And not just try to fix it in these two, either a human being or a person or a thing that you can own. And I would think that the genetic information should not be patented as property or as an invention, but that somehow it is a common heritage of mankind that maybe we need specific juridical arrangements for these kind of things. But it needs much further thought, I think.
Well, thank you very much, Dr. Anderson, Dr. Jochumsen.